Mensuration, solid shapes. So here we shall be taking on surface area and volume. We take the first problem. The diagram below is a wooden material in the form of a prism. ABC is a right-angled triangle. Calculate A, AC. B, total surface area of the material. C, volume of wood in the material. So from the question, this is a wooden material in the form of prism, and here ABC is a right angle triangle. We need to calculate AC. So we pick on the first part of the problem, A. To calculate AC, since ABC is a right angle triangle, we shall be using Pythagoras theorem, so that we have our AC squared, which is the hypotenuse, is equal to 6 squared plus 8 squared. So that will give us 36 plus 64, giving us 100. AC squared is 100. Therefore, AC is equal to square root of 100, which is 10 centimeters. So therefore, AC is 10 centimeters. Then we go to the B part of the problem, total surface area of the material. To calculate the total surface area of the material, we are going to calculate the area of this triangle ABC, which is the same thing as the area of triangle DEF. So from there, we now calculate the area of rectangle ACDE, also the area of rectangle ABFE, and then the area of the base triangle rectangle BCDF. So from here we have a total surface area is equal to 2 times the area of the triangle ABC. We are coming with this because triangle ABC is equal to triangle DEF. We need to calculate the area of one of the triangles and multiply by 2. That's what we are going to do here. Then plus area of rectangle ACDE. ACDE, that's the one directly facing us, plus area of rectangle ABFE. ABFE, the one at the back of this one facing us, and then finally plus the area of rectangle BCDF, that is the rectangular base. So here we have it as 8 times 6, since area of a triangle is half base times height, and we are multiplying by 2. We can just take the base, multiply by the height to give us the area of the 2 triangles. Then plus 12 times 10, this is 12, and this is 10 that we have calculated. Then plus area of this, that's going to be 12 times 6, this is 12, and this one is 6. And finally, we are going to have it as plus 12 times 8. So we now simplify. 8 times 6 is 48. 12 times 10 is 120. 12 times 6 is 72. And 12 times 8 is 96. Adding them together, I have the total surface area of the material as 336 centimeters squared. We go to the C part of the question. The C part of the question is asking us to calculate the volume of wood in the material. To calculate the volume, we can just take this triangle as a base, since it is a uniform section of the shape. So we just take the triangle as the base, calculate the area of the triangle, and multiply by the height, since volume is base area times height. So we are going to take this base as the triangle, then multiply by the height. We are taking the triangle as the base because it is the uniform section of the shape. We cannot take this rectangular base because it is not uniform. So from here, the base area here is a half times 8 times 6, then multiply by the height, which is 12. So from our calculator, we can easily simplify the final answer to be 288 cubic centimeters, which brings the end of the solution of question BQ1.
Now the second problem on surface area and volume. A solid cylindrical metallic object is 20 centimeters long and has a diameter of 7 centimeters. Calculate A. Total surface area of the object. B. Volume of the object. Take pi to be 22/7. The solid cylindrical metallic object is this. Everything is covered, solid. The circular faces and the curved surface are covered. So to calculate the total surface area, we find the two circular faces, the area of the two circular faces, which is 2 pi r squared, and plus the area of the curved surface, which is 2 pi rh. So we have 2 pi r here, 2 pi r here. We factorize 2 pi r into r plus h. Then we now substitute into this formula to get the total surface area of the cylindrical metallic object. Now we have 2 pi is 22/7, r is 7/2. Since the diameter is 7, so the radius is 7 divided by 2. That will give us 7/2 times 7/2 plus 20 squared centimeters. So now this 7 goes with this 7, this 2 goes with this 2. We are left with 22 here. Now 7/2 is 3.5. 3.5 plus 20 gives 23.5. So we have 22 times 23.5. And from our calculator, we have it as 507 squared centimeters. Then we go to the B part of the problem. We have to calculate the volume of the object. So the formula for the volume of the object is pi r squared h. Again, pi is 22/7. The radius, which is 7/2 squared, will be 7/2 times 7/2. We have expanded the squared, so multiply by the height, which is 20 centimeters. So 7 cancels 7. 2 goes here. 1, 2 goes here, 11. 2 goes into 2, 1. 2 goes into 20 gives 10. So 11 times 7 is 77. 77 times 10 gives 707 cubic centimeters. That is the end of the solution to the second problem on surface area and volume. Please remember to subscribe to our YouTube channel, Oninabi Resources, and like this video. Then we go to the next problem.
So the third problem, a sector of a circle of radius 15 centimeters, which subtends angle 216 degrees at the center of the circle, is bent to form a cone. Calculate the volume of the cone. So in digesting this problem, we need to know the relationship between a sector of a circle and a cone. It is important to know that the radius of this sector is going to form the slant height of the cone, and the circumference of the circular base of the cone formed we now form the length of the arc of the sector of the circle. So from here, we need a sketch of the cone. So the sketch of this cone is given. We have told us the slant height is represented by the radius of the sector of the circle. Now, we need to look at the relationship between the radius of the base circle of the cone and the radius of the sector of the circle. So we have this as r is equal to theta, that is 216 over 360 times the radius of the sector to get the radius of the cone. So from here, I have my answer as 9 centimeters. So we now go ahead again to find the h, that is the height of the cone. From here, since we've known this, we can now use Pythagoras theorem, so that we have our h squared is equal to 15 squared minus 9 squared, since the radius is 9. So we have 225 minus 81, giving us 144. So h now is square root of 144, which will give us 12 centimeters. We can now go ahead to calculate the volume of the cone, which is 1 over 3 pi r squared h. We have 1 over 3 times 22 over 7 times radius. Our radius here is 9. So we have 9 over 1 times 9 over 1, then times h. Our h is 12. So multiply by 12 over 1. I can easily multiply the numerators and divide by the denominators. So that will give me 1018.286 cubic centimeters. And to 3 significant figures, I have my answer as 1020 cubic centimeters. Addition and subtraction of volumes. So we'll be having our fourth problem. A square-based pyramid is mounted on a cube as shown in the diagram below. Calculate the volume of the composite solid formed. So here is a combination of a cube and a square-based pyramid. So to calculate the volume of this object or composite solid, we shall calculate the volume of the cube and the volume of the square-based pyramid. So we start with the volume of the cube. This length is 6 centimeters. It means the height and the breadth of the cube is also 6 centimeters each. So we now have it as 6 raised to the power 3, as volume of cube is L cube. So with this L cube, we have it as 6 times 6 times 6. And that will give us 216 cubic centimeters. Then we now calculate the volume of the pyramid, which is 1 over 3 times 6 squared times the height of the pyramid. Since from here to this place is 6, therefore the height of the pyramid is 4 centimeters. So we now multiply by the height, which is 4 centimeters. So from our calculator, we have our answer as 48 cubic centimeters. Therefore, the volume of the composite solid formed is going to be 216 plus 48, which gives 264 cubic centimeters. Problem 5. The diagram below shows a composite solid consisting of a cone on top of a cylinder with common diameter 28 centimeters. Calculate the volume of the solid to 3 significant figures. So we already have the diagram here, a cylinder. We need to calculate the volume of the cylinder, calculate the volume of the cone, and add them together. So we start with the volume of the cylinder, which is 22/7 times r squared times height, which is 15. So from my calculator, I have 9,240 cubic centimeters, which represent the volume of the cylinder. Then we'll go for the volume of the cone, 1/3 by r squared h. So multiply by the h, 10 centimeters. From my calculator, I have 2,053.333 cubic centimeters. Therefore, the volume of the solid is 9,240 plus 2,053.333, and adding this together, we have 11,293.333 cubic centimeters. And to three significant figures, as indicated in the problem, we have 11,300 cubic centimeters, which gives the volume of this composite shape to three significant figures. Problem 6. The diagram below shows a cylindrical casting of height 14 centimeters and internal and external diameters 8 centimeters and 10 centimeters respectively. Calculate the volume of metal in the casting. So we are given the internal diameter and the external diameter to be 10 centimeters. So to get our external radius, we have it as 5 centimeters. And to get our internal diameter, we have 8 divided by 2, which gives 4 centimeters. We have to calculate the volume of the cylinder with the external dimensions and the volume of the cylinder with the internal dimensions, and find the difference. So we start with the volume using the external volume of the cylinder. So we have 22/7 times 5 times 5 times the height, which is 14 centimeters. From here, I have my answer as 1,100 cubic centimeters. Then the internal volume, that is the volume of the shape with internal dimensions, we have it as 22/7 times 4/1 times 4/1, then times 14/1, since they have common heights. So we have this from our calculator, 704 cubic centimeters. Therefore, the volume of the metal in the casting is 1,100 minus 704 cubic centimeters. So from here we have our answer as 396 cubic centimeters, which gives the volume of the metal in the casting. Problem 7. The diagram shows an open rectangular box made of wood 3 cm thick. The internal dimensions are 45 centimeters long, 30 centimeters wide, and 20 centimeters deep. Calculate the volume of wood in the box. So this is a box with an open end. It is just one end open, the top being open, the bottom being closed. So to find this, we are given the internal dimensions, so we need the external dimensions. So for our external dimensions, we are going to have the length, which is 51 centimeters long. Since the box is 3 centimeters thick, so at both ends of the length we have 3 threes. That is, to get the external dimension, now we are going to add 3 to both ends, so that we now have it 45 plus 6, giving us 51. In the case of the width, we do the same thing. 3 from both ends, making 6. Add it to the internal width. We have it as 36 centimeter wide. And for the depth, since it is open at one end, we are only going to add 3 centimeters. That is the thickness at the bottom, which gives 23 centimeters deep. So to calculate the volume of the wood in the box, we calculate the volume using the internal dimension and the external dimension and find the difference. Start with external volume, which is length times breadth times height. That's 51 times 36 times 23 cubic centimeters, which gives 42,228 cubic centimeters. And the volume using the internal dimensions, we have the length 45 centimeters, the breadth 30, and the height 20 cubic centimeters. From our calculator, we have 27,000 cubic centimeters. And again, to get the volume of wood in the box, it is the volume using the external dimension minus the volume using the internal dimension, so that we will now have it at 15,228 cubic centimeters, which gives the volume of wood in the box. Problem 8. The diagram represents a cross-section of a concrete block 2 centimeters thick and 30 centimeters long. Calculate the volume of the concrete in the block. B. The mass of the block if 1 cubic centimeters of the block is 3.8 grams. So to calculate the volume, we shall calculate the volume of the shaded portion in this diagram and multiply by the height. So to get the dimension of the internal rectangle here, we shall be subtracting 4 centimeters from both the length and the breadth to get the internal dimension of, to get the dimensions of the internal rectangle. So to get the volume, we have the internal dimensions 21 centimeters, subtracting 2 from both ends of the length, so we have 21 centimeters. The same thing, subtracting 2 from both ends, that's 18 minus 4, which will give us 14 centimeters. So the rectangle inside the shape here is 21 centimeter long and 14 centimeter wide. Then we now have the common height to be 30 centimeters. So the external volume is going to give us 25 centimeters by 18 centimeters, then multiply by 30 centimeters cube. So that will give us 13,500 cubic centimeters, and the internal volume, that's going to give us 21 centimeters multiplied by 14 and multiplied by 30 centimeters. So, and from our calculator, we have 8,820 cubic centimeters. Now the volume of the concrete block now is going to be the external volume minus the internal volume, and that will give us 4,680 cubic centimeters. By that, we would have solved problem A. Then we now go to problem B. Problem B. The mass of the block if 1 cubic centimeters of the block is 3.8 grams. So we know 1 cubic centimeters is equal to 3.8 grams. So as such, 4,680 cubic centimeters will now give us the mass of the block. By cross multiplying, the mass of the block will now be 4,680 multiply by 3.8 grams. So here we will have it as 17,784 grams, and to kilograms in three significant figures we have it as 17.9 kilograms, and that is the mass of the block in kilograms to three significant figures. Problem 9. The internal diameters of the top and bottom of a bucket are respectively 24 centimeters and 18 centimeters. If the bucket is 15 centimeters deep, calculate the capacity of the bucket. To do this, we are going to take a sketch of the bucket. So we have the bucket with the top radius 12 centimeters, since the top diameter is 24, and the bottom radius is 9 centimeters, that is 18 divided by 2, and the height is 15 centimeters. So this is not a common shape. We are going to produce a common shape from this by drawing a complete cone from the frustum. So to do that, we extend the slight height and get the complete height. So we need to calculate this height of this small cylinder, and to do that we are going to use the principle of similar triangles. That is, the ratio of their sides are equal. So we now have h over 9, taking this triangle, is equal to, taking the large triangle, 15 plus h over 12. So cross multiply, 12h is equal to 135 plus 9h. Bringing this to this side, 12h minus 9h gives 3h, which is equal to 135, and h is 135 divided by 3, and that gives 45 centimeters. Now to calculate the volume of the bucket in this case, since to calculate the capacity we need to calculate the volume and convert it to capacity. So to calculate the volume of the bucket, we need to calculate the volume of the entire cone and then the volume of the small cone, take their difference, and we will get the volume of the bucket. So we have the volume of the bucket to be the 1 over 3 pi into r squared h minus r squared h. This is representing the radius of the larger cone, while this h is representing the height of the larger cone, and the small radius here is representing the radius of the smaller cone, and the small h represents the height of the smaller cone. So we have it as 1 over 3 times 22 over 7 times radius of the larger cone is 12 squared times 60. That's 15 plus h. Now h is 45. So minus small radius 9 squared multiplied by 45. And here we have 1 over 3 times 22 over 7. 12 squared times 60 gives 8,640 minus 9 squared times 45 gives 3,645 cubic centimeters. This times this gives 22 over 21 times the difference between 8,640 and 3,645 is 4,995. By multiplying this, we have our answer as 5,232.857 cubic centimeters, which is the volume of the bucket. Now to calculate the capacity of the bucket, we are going to divide the volume by 1000, since 1000 cubic centimeters is equal to 1 liter. So we have it as 5.23 liters to 3 significant figures. Problem 10. A frustum of a pyramid is 4 centimeters squared at the top, 8 centimeters squared at the bottom, and 10 centimeters high. Calculate the volume of the frustum of the pyramid. So to do that, we need a sketch and a complete pyramid to give us sense of calculation. So we need to calculate the height of the smaller pyramid. As usual, we use similar triangles here. H over 4 is equal to 10 plus H over 8. So cross multiplying, 8H is equal to 40 plus 4H. Bring this to this side. 4H is equal to 40 and H is equal to 10. So we get to the main business. Calculate the volume of the entire pyramid minus the volume of the smaller pyramid. Volume of the frustum now is 1 over 3 b squared h minus b squared h. The capital letters represent the dimensions of the larger pyramid, while the small letters represent the dimensions of the smaller pyramid. So I have 1 over 3 times 8 squared times 20, since 10 plus 10 is 20, minus 4 squared times 10, that's 1 over 3, 8 squared times 20 gives 1280, minus 4 squared times 10 gives 160, and from here I have 1 over 3 times 1120. Dividing this by 3, I have 373.333 cubic centimeters, and to 3 significant figures, I have 373 cubic centimeters, which represents the volume of frustum of the pyramid. This brings the solution of problem 10 to an end.